We're on page 380.
John has a story to tell me.
Okay.
It's on?
Yeah.
Oh, hi. What page? Story time.
No. Take a rain check on that in the class. Page 380. Here we go. 7-5. We are finding the areas of regular polygons. Okay. What's a polygon? It's a shape. Give me a little bit more about it. Give me an example of a polygon.
Have 5 sides.
5-sided polygon has a name that's, what is it called? Pentagon. Okay. What's the smallest number of sides that a polygon can have?
5.
What's it called if it has 4?
Square.
A square. It's still a polygon though. Okay? A 4-sided figure is really called a quadrilateral. The one that's most common that we say, when we say square, we're saying something with 4 sides. We know that if we get technical, it means it's got 4 right angles and 4 congruent sides. But there are shapes that are polygons that don't have those qualities and have 4 sides, and they're called quadrilaterals. That's a big word, like if I said students, and then I said sophomores. Sophomores would be more specific, right? Students would be very general. Could you make a polygon with less than 4 sides? Could you make one with 3 sides? Is there a shape out there in the world that's got 3 sides? It's called a triangle. Is a triangle a polygon? Yes, it is. Can you make one with 2 sides? No, because every time I see 2 sides, I either see absolute value bars, or if they're touching in one spot, then I've got a what? An angle, but they're not. It's not a closed figure. See, that's what a polygon is. A polygon is a closed figure made up with line segments, the smallest of which we can have is 3. What if you just have one line segment? What do you have? You just got a line, right? You don't have a shape. So a polygon can have 3 or more sides. How many vertices does a triangle have? Since that's the smallest number of sides, how many vertices does a triangle have? How many angles does it have? 3. So it's the same number of sides as the number of angles. So what about a pentagon? You said a pentagon has 5 sides, so how many angles would it have? 5. What's a octagon? 8 sides. It also has 8 angles. Okay? What's a quadrilateral have? 4 sides and... Okay. Tell me about a triangle. Tell me everything you know about a triangle. Equals 180. That she says equals 180. What equals 180? What if I'm just walked in here from 5th grade and you said triangle equals 180? And I don't know what you're talking about, so tell me.
But all the angles should add up to 90.
The angles add up to 180 degrees. Okay? Well, now how many are there? 3. There's a lot of different ways I can get 180, right? If I told you that all the angles had to be the same size, would you know exactly what size they were? Would you? How? 180 divided by 3 is 60. So if all the angles have to be the same size, then there's only one answer for how big the angles are, right? And it would have to be 60. Okay, that's a triangle. What was the next one? Quadrilateral. How many sides did you tell me they had? 4. How many degrees are in a quadrilateral? 4 sides, 4 angles. How many degrees? Is it 180 as well? 360? So you're taking that little piece of information is true, and you're saying, okay, every four-sided figure must fall into that rule. Okay, 360 is correct. The reasoning on why is probably not the best explanation, but it's a way to get your answer. So let me put this chart on the board over here. You said we had three sides. It was called a triangle, and it had 180 degrees. Quadrilateral had four sides, and you said it was 360, right? Okay, five sides. Let me draw what we have here. Triangle, quadrilateral, and pentagon. Let's look at those. The way you determine how many degrees are in each of these figures is by dividing it into triangles. Since you know a triangle, 180, that's the first thing you tell me about a triangle, then what you need to do is say, I'm going to take this figure and I'm going to see how many triangles it takes to build it. The least number of triangles I can put together to build that. So if I do that, then I could use two triangles to build that. Do you agree? And 2 times 180 is 360. Okay, what about the pentagon? What's the least amount of triangles that I would need in order to build that? 3. So each one of those would contain 180 degrees. So pentagon has 5 sides, and it would be what?
$5.40.
540. Okay, this is number of sides, and then I'm going to make another column in here. Number of triangles. How many triangles are in a triangle? How many triangles are in a quadrilateral? How many are in a pentagon? 3. Hexagon has 6 sides. Let me see if I can draw this. Mm-hmm. Bear with my drawing, please. It's my attempt at a 6-sided figure. How many triangles what's the least amount of triangles I could use to build it? And you don't have to divide yours the same way that I do. We just have to make sure we're using the least amount possible. Can I do this and this? So I've got 2 triangles already, and then what shape's left in the middle that I still have to work on? How's the best way to handle that? Okay. So how many triangles did it take to build a hexagon? 4. Okay. You notice anything? What you notice? Okay. Well, look at it like this. Look at that. A 4-sided figure has 2 triangles, right? A 5-sided figure has, a 6-sided figure has, you're subtracting 2. So if I came down here and I said, ooh, I've got a 13 gone, that's what the name would be. How many triangles do you think it would divide into? 11. And what number would go here? 11 times 180.
1,980.
Okay. So that's how we figure out how many degrees are inside of these polygons. If it's a regular polygon, the word regular means something. Most of the time, if you're ordering a hamburger and you say, I want a regular hamburger, you mean ordinary, right? Not special. Most of the time, in our language, regular means ordinary, not special. You want this? I just want a regular pepperoni pizza. I mean, I don't want anything extra. I don't want anything specialized. But in geometry, when we use the word regular, it doesn't mean, oh, it's just any old kind. It's just ordinary or most common. It has very, very specific meaning. What it means is every side is the same and every angle is the same. So if I tell you you have a regular polygon and it's a regular pentagon, how many sides does it have? How many angles? 5. The total on the angles is 540. If it's regular, every one of them has to be the same. So can you figure out the measure of each one? What'd you get? 108. So on a regular hexagon, what would you do to tell me the measure of each angle on a regular hexagon?
Yeah.
120. Okay, we kind of got the picture here? Well, what we're going to be doing today is we're going to be finding the area of these things. We're going to have this, page 380 says you can circumscribe a circle about any regular polygon. That means you can draw a circle around it. If I draw, and this is, y'all, look in your book. You know I can draw that. They have drawn a circle around this hexagon. From the center of the circle to the vertex is the radius of the circle. You see that? You following with me? The radius is the distance from the center to the vertex. There's a new word here that you've never heard before. It's called apothem. An apothem is a perpendicular distance from the center to the side of the figure. Does the apothem touch the circle? No. Do you know when we work on other things, we have something called a height? And remember, Miss Lumpkin always said, the height's got to be perpendicular. This is a height equivalent. It's not the height, but it does that same job. It has to be perpendicular. Okay. So finding the angle measure. The figure at the right is a regular pentagon. The word regular means something. Doesn't mean ordinary. It means it's all the same. With radii and apothem drawn, find the measure of each numbered angle. Okay, what's the measure of the angle if it's in a regular pentagon? 108. Okay? So every corner measure is 108. They want you to find the measure of angle 1 right here. The measure of angle 1. How many angles are there the size of angle 1 in the middle of that picture? I think I can draw a pentagon. Okay, this is terrible representation. But my question is, how many of these angles are there? 1, 2, 3, 4, 5. There's 5 of them, right? They're supposed to all be the same size. In the middle, we have a circle. If a circle is divided into 5 equal parts, how big is each part? I don't know. How many degrees are in a circle? Okay. So in that triangle that they've drawn here, go back to the book, it looks a lot better. That angle is 72 degrees. Now, what about angle 2? What about angle 2? What do you think about it? Where is it located? It's located in a right triangle. It's part of one of those sections, isn't it? Do you think angle 2 is bigger than angle 1 or smaller than angle 1? Do you think it has a relationship with angle 1? You think it's half. You're right. Because what we've done is we have divided it into two equal parts. So if that one was 72, what's the other one going to have to be? 36. Now what about angle 3? What do you think about angle 3? Well, if you know 1 and 2, can't you figure out 3? $54. Now what did you tell me one of these over here were going to be the whole thing? Is 54 half of 108? So that makes it makes sense? Okay. At the right, a portion of a regular octagon has radii and apothem drawn. Find the measure of each numbered angle. Well, 1, 2, 3, 4. This is half the picture. If it's an octagon, how many sections do we have? Octagon. 8. Okay? 8 angles in the middle that would go together to make a circle. So how big would each angle be? If it takes 8 of them to make 360 degrees, each angle is 45. So the measure of angle 1 is 45. What about the measure of angle 2? Is it smaller than angle 1 or bigger than angle 1? Smaller. Is there a relationship between the two? It's half, so that means 45 divided by 2 is 22.5. Now how would you find measure of angle 3? No, subtract from 180. Okay. So here's what we have. You have a regular n-gon with S sides. The radii divide the figure into n congruent isosceles triangles. That means how many wedges do we have? If we have 8 sides, we have 8 wedges. If we have 5 sides, we have 5 wedges. Since there are n congruent triangles, n times 1/2 AS is your area. The perimeter of the n-gon is n times S. That's the number of sides times how big each side is. Substituting P for the n results in a formula for the area, which is A equals 1/2 the apothem times the perimeter. Okay? So you need to know the perimeter of the shape, and you need to know the length of the apothem in order to find its area. So let's look at our example 2 here. Find the area of a regular decagon. What does that mean? What is a decagon? How many sides does it have? 10 sides. How big is each side? In this picture, how big is each side? 8. So what's the perimeter? Claire, how do you find perimeter? You got 10 sides and every one of them's 8. So what do you think? Distance all the way around. Perimeter's 80. I need to know the apothem. Do they tell that to me? The apothem goes from the center to the side and it's perpendicular, so it's right there. So for my formula, I need 1/2 the apothem, which is 12.3, times the perimeter, which is 80. And when you multiply those, you should get 492. Did you get that? Okay. Okay, moving right along, let's go to the next example. I'm turning the page. Example 3. I don't want to run out of time. I better give y'all homework. We better cut this lesson in half. So today, page 382, one through nine all, 46, 47, 'm gonna stop there.